Sarah, thank you very much for the introduction. Possibly the grandest I've ever received, so thank you. I'm also going to add, I'm also a geologist, so hey, we're everywhere. And I suppose if there happens to be some younger geologists out there, I'm a geologist that graduated 20 odd years ago and now is a circular economy group manager. So yeah, there's lots of ways you can go, and started out in mining as well. So fascinating introduction. Thanks, Sarah. I'll run through this really quickly because I know the aim of the conference is to get some active discussion. So look, this is going to be a high level summary of the Institute, where we are, what we do, what we're all about, and then hopefully we can engage in further discussions as well after that. So Materials Processing Institute is in Northeast England. Don't let the accent fool you. I'm actually born and bred in Scotland, but been living in Teesside for the last 20 years. Teesside, if you're based in the UK or read a lot about the UK press, Teesside's become pretty popular recently. The government are moving up here to Darlington. That's just nearby. They're putting the treasure in there. So there's a lot happening up here. Freeport, Teesside's got a Freeport. Anglo-American are building the Sirius Minerals project over at York Potash. There's a lot going on around but here. Materials Processing Institute is British Steel's old R&D facilities. 7 years we broke away from what was then Tata Steel, formed our own RTO, Research and Technology Organisation, out of the existing infrastructure, and we are based now on 4 key pillars, whereas in the past we were very much focused on the steel and metal sector. Now we're looking at 4 core areas, and we make we hide no shame in the fact that these are the areas that the government is putting their funding towards. Advanced materials, new materials that are for new processes, new products, circular economy, getting a better security of supply, promoting recycling and using materials much more efficiently, which totally aligns with all the things that Sarah's just been saying about efficient and resource efficient use of materials that we have to extract at some point. We also focus on industrial decarbonisation because that is the biggest challenge of our existence, if I'm perfectly honest. That's it. That's the ball game. And if we don't decarbonise, the world's going to be a different place in 100 years. And digitalisation is actually, I suppose, something that knits it all together. A lot of the foundation industries, the old manufacturing, old production industries are still based in technologies from the last 200 years that have been running similar since. So what we're trying to do is develop ways that modern production techniques, measurement, analysis, processing can support. And ultimately that improves efficiency and efficient use of materials as well. So those are the areas we focus on. My predominant focus is obviously circular economy. That's the group I manage. In terms of where we sit as an RTO, we're in that, I didn't put the side up there, but you can't avoid saying it because everybody talks about it. It's the innovation valley of death. It's that bit in the middle where there are millions of good ideas and very few of them found their way out to production. So we try and bridge that gap. We try and support prototype, pilot scale, validation, proving of concepts, and proving that they can commercially succeed. So I'm not going to spend a lot of time on that, but that's what we try and do. What have we got in terms of facilities? We've got some, I've just come off a call talking to some people in the cement industry, and our chief technology officer described these as our toys, which is slightly underplaying them. The picture on the left is a 7.5 ton electric arc furnace. So we melt scrap steel. We make different types of steel. We can produce small ingots, and we have a continuous casting facility as well, a Comcast facility, which can produce beam bars and other types of products. As well as those bigger toys, we've got a load of laboratory thermal modeling equipment, thermal testing, petrography and mineralogy, you know, the list's endless. We've got it all, and we've just recently received a government grant, so we've upgraded it. So we have state-of-the-art scanning microscopy. Yeah, and that's an area that we can, if anybody wants to learn more about, once the lockdown's all over, you're more than welcome to come and see it. What do we do, or what are we doing with this money that the government have given us? We're going to improve what we've got. And this is what I was really excited listening to what Sarah was saying. We're going to improve our existing assets, and we're focusing on all the different things that we're talking about, which is, we're calling it our Circular Economy Technology Centre. We're putting in assets to improve manual handling, separation of materials. We're putting in assets to try new mineral process technologies. Revert material from the steel industry is a huge resource potentially for future exploitation. We are putting facilities on the ground to allow that research and development to take place and to prove these concepts. We're also putting in equipment that we believe will be an enabler to improve the circularity in end of life materials, end of life batteries, end of life renewable products, because we all know the dichotomy of all these wonderful renewable technologies and how they reach the end of their life and people are just sticking them back in the ground. So that's what we're trying to do with the funding we've got and the investment we're making and the partnerships we're building. So one of my colleagues said, when you mention the enhancement of our existing assets, make sure you get it across, and it is firmly my message that we want to engage with anybody that wants to talk to us about what are the right assets for your industry. So you know, come and talk to us, learn more about us through this presentation, and also have a think, because we want to be the place that things can get trialed and things can get proven, and just work with everybody. You know, we're an RTO, we're a not-for-profit organization, so we don't have to I think the phrase we use is technology agnostic. We'll happily support anything, any technologies. And scrap, I mean, we're still metal experts, so we still focus on scrap processing and scrap metal recovery and upcycling of scrap. So a very quick summary of some of the recent projects we've done. We have just finished a project where we have demonstrated that a technology from the steel industry that is used to recover graphite can actually recover lithium from electric vehicle batteries. And the next stage of that is to try and upscale and prove that can be done to feed materials into a manufacturing process. We are looking at waste from steel plants that are iron rich, because historically they weren't able to extract as much iron as they could today with modern processes. So we're working with a number of legacy steel sites to do that. We're also using wastes and slags from industry and reprocessing them to turn them into high quality road aggregates, road surfacing materials, and everything in between. So we're in a really exciting time, a really exciting place at the moment, and we're really keen to engage, which is why it's a great opportunity that Sarah's presented with us to come and tell you a wee bit about us and hopefully lead to more discussions. I think that's pretty much all I've got. Yeah, I was going to try and keep it to 5 to 7 minutes. Have I done that?
You've nailed it, sir. Absolutely nailed it. Amazing. So ladies and gentlemen, please put your hands together for the wonderful Andrew Buchanan. So thank you very, very much for that very quick overview into some really exciting projects that you've got going, Andrew. I mean, I've got a whole list of questions this end, and I'm sure many of our attendees do as well. So if you've got questions for Andrew, please put them into the Q&A or into the chat function as well. And if you're on YouTube, please stick them into chat and we'll pull them across as well. So Andrew, I'm really interested in what you mentioned about the ability to pull some of the lithium out of the electric vehicle batteries. Am I right in saying at the moment that the vast majority of that lithium, so those batteries are not being built at the moment to be recycled? And so is that correct?
Yeah, I think the way you phrased that, Sarah, is perfect. I've got 7 minutes to talk about it. You've got to, one of the other areas we really want to start engaging with all the manufacturers is trying to think recovery rather than just, because everything we have is focused on making it smaller and nicer looking, with no thought at all on what happens at the end of life. So it is, and somebody could argue with me, but in terms of the vast majority of these products, none of them are built to be for the materials to be recovered. Wind turbines is actually a better example in terms of scale, but I mean, lithium-ion batteries is another good one. Wind turbines they're currently designing the next generation of wind turbines for offshore wind, and nobody is looking at how all the power systems, the copper, the aluminium, the electromagnets, the rare earth elements, the rare earths that's refined all over the world and brought into the manufacturing process. Nobody is thinking about how that can be recovered, and that's what we are trying to. First of all, figure out the ways to get it out of the equipment that's already been manufactured, but try and change the view, change the. I mean, it's a massive change that's needed, but that's what we want to do.
Yeah. No, that's, I mean, it just, so for many of the people who are listening into this and work in the mining industry and know the effort that goes into getting those raw materials out of the ground and processing the first time that they kind of almost come around. So it's almost really disappointing to hear that nothing is being designed, or it's very rare that something is designed to be reused, repurposed, recycled. There's a question that's come in from John Clark, and he's asking, are there any plans in place to say, well, actually, if we look at a waste tip, as in a rubbish dump or a garbage dump, of looking at that as being a kind of a resource, and then saying, how might we be able to mine that or process that? John, I realize I haven't quite asked your question, but I've been inspired by your question.
Yeah, no, I see that. I mean, it's the oldest answer in the book. Part of the problem is that it's waste. For every meter you think you know what you've got, the next meter you've got no idea. And then the economics is so difficult to control. People want steady streams, constant material, and a steady output. So the reason urban mining it's been called for years. I mean, it's not a new concept. The reason it's not taken off is because the financial case is just not there. You've got so many byproducts. So, and that has to be dealt with, and the costs of managing them. So it's a multi-component answer. There's obviously needs to be changes in terms of how the assets are managed, what benefits are given to the companies that try these things out, but also there has to be primary research to understand where the real value can be extracted. I'm really interested in a project that I've been talking about in the leachates from these, which is almost an easy thing to think about, because it's controlled and it's captured, and there's definitely some interesting materials caught in there. But it is a great question, John. It should be easier than it is, but equally, it's not, because what's in there is not well defined. It's a mess.
So I think, Andrew, with that, as you can see, the questions are coming in thick and fast for you. But in the interest of time, I'm going to have to move on. But one last question for you. Where did you do your undergraduate in geology?
Glasgow.
Get in. We've got two of us who did geology at Glasgow University. There we go. Fantastic.
It was called geology and applied geology when I did it. And yeah, we could have a conversation about some old lecturers that are probably no longer with us, but yeah, maybe not you. You've only been there a few years ago, but I was there quite a while back.
Thank you very much, sir.
Yes, charming, yes.
So ladies and gentlemen, I'm going to invite you to put your hands together and say a massive thank you very, very much to Andrew for that. I'm